Okay. Let's see. Did that start streaming? Bit of a delay here. Yep. There we go. Okay. I actually have no idea what the hell this function does. I am going to look at it and see if it's used anywhere. Because it doesn't really make sense as, um, yeah, the errors would be printed by default, so I'm a little confused how this makes any sense. I don't know what I was thinking when I made this function. And that doesn't actually make any sense because you have that one there. It doesn't make any sense. I'm gonna see if it's actually used. If not, I think I'll just delete it. Because I don't know. I don't know what I was thinking. There's a lot of things in here that just need to go, and need to be changed. So it's here. Print error. Yeah, that's weird. That's like it isn't. We don't really have to check. That's the thing. There's not a reason to check this. Oh, whoops. Not a reason to check this because by default it'll print an error if the operation is not allowed. I guess this was so I could catch it early. We'll keep it, because I don't really want to think about the logistics of replacing it, but it's a bit dumb and we need to make one little change, which is to say, right here, we'll just, whoops, we'll just say, if op equals not, then we'll do, yeah, we'll do CLS dot underscore not, and we'll put in the right hand side only. So I think that should work. I feel like we should actually create a, whoops, like a decorator. That's what I'm trying to say. I think we should create a decorator, maybe. And the whole point of the decorator would be like, this is an operation, and so that way it can kind of have maybe like a guard clause almost by default, where it's like, okay, if func is none here, then but print an error. If it do some stuff by default, and maybe make it a little easier to do things, I guess. Like, maybe not have to do all of this garbage. But I think it's just gonna have to be like that anyway. I don't have like an IAdd or ISUM, like the in place operations. For these there are no in place operations. And maybe I should add like a almost a property for that, but I don't know. What is all this? Oh, these files don't exist, I thought. I thought I deleted those. Oh, these .so files do exist. Oh, I guess there's a build directory now. I didn't realize there's a build directory. There's .o files for object files. Yeah, I was experimenting to see if I could get memory usage down by using Python structs, and I learned that it's not really worth the effort and doesn't really appear to do much. So if I go to Discord real quick and I open this in another browser real quick, if I look at this was the memory usage graph over time. So this is just how it appeared. looks kind of weird. This big 37 megabyte jump is actually, if I can pull the image from another chat, that's the one I want. Here, yeah, here's one of the images, and then there's another one. This is memory usage at that point in time, quite high, actually. Or, well, this is actually after that operation, so this is what it would be after you've added this in. So, this is from LLVM, like, import, binding, and IR, and so then I separated those out, and figured out IR is basically, like, that doesn't do much, which is kind of what I expected, because they import IR, like, all over the place. Which I think I undid a lot of that, because I realized it didn't really make sense since I already have the objects being passed around, and I didn't really need to, like, make a new builder or anything, so it's, I don't know, it's hard to explain. But this binding, this LLVM like that binding, and I mean, there's not much they can really do about it being 37.6 megabytes. And then if you create this execution engine thingy, this binding that create MC, oh, I just didn't have Copilot. I just realized what that is. So this is actually taken from tutorial code. I will be very much honest about that. It is taken from some tutorial code about how to make a compiler in Python that I was originally following when I first got started. And I haven't changed the code for myself because I haven't had a reason to. And delving into the LLVM like binding layer sounds really painful, and I don't want to do that until I'm ready to. So I'm not going to, obviously, not until I'm ready. But it's a 3.5 megabyte object, which is kind of ridiculous, right? But that's kind of where these, like, jumps come in, is this whole thing is, like, doing those operations, creating an object and then importing the binding layer. And this is still visible, like, I can't do anything about this. All this stuff, I mean, that's to be expected. So what I think this is like, you know, normal imports. It's getting Python started. It kind of just does that, and then you have like the strings and shit, and then it gets converted to the parser token objects, and that would probably use up a good amount of memory, and that's to be expected. That's one of the things I tried to reduce memory usage when I was trying to play around with the Python structs. Which didn't really work that well. So, I mean, that's to be expected. There might be something I can actually do about this fairly steady, like, 10 megabyte jump over the course of the compile time. But I can't do anything about this. So, because there's nothing I can do about that, what I actually did, and this isn't recommended that you do it this way, what I did was where is it? I opened up like everything yesterday, and I had to revert all those changes anyway, it didn't really matter. I just made some temporary variables and stuff. So I get the memory before I do any imports, and that way, because I only want to subtract the import. So I want to know the baseline memory usage of the program before I do the import. So that way when I subtract it from the memory usage after the import, I know I'm only grabbing the memories for that import. So, yeah. And then at the end, when I output the memory usage, I subtract that from the current memory usage at the end. And then I divide by 1,000 and do a little bit of float formatting. And that's kilobytes now instead of bytes. Just because I thought that might make more sense. It might actually make more sense as megabytes, just considering what the compiler uses. I might create a function to automatically bring it down to like the lowest it can be and just automatically do the formatting. I'm not really sure. But, for the time being, this works, and I'm only doing this mainly so in development I can see how much memory I have control over. And yesterday it was like, 96 megabytes or whatever. I couldn't figure out for the life of me what that was. I think I figured it out, and it was the LLVM like binding layer. But what I did was I just did a make clean. Whoops, make clean. And what that does is it deletes all the pi cache and also the virtual environment entirely, which I can show you in this make file here. So, it'll make a new virtual environment and install the packages on its own, doing all that stuff. But this make clean just gets rid of the pi cache virtual environment. There's also a Sphinx clean, which deletes the built docs. So that's pretty nice. This is Sphinx build, obviously. And then I also added unit test, which is when I was doing the testing on stream, last stream. And then I did profile CPU. So if I actually do make profile CPU, what that does is that pulls up this cool visualizer I found called Snake Viz. It's very bright on my screen. Sorry, let me try to minimize it a little bit. Maybe it'll be less bright. So that's what this is. I'm not quite sure. So I think this is like call stacks and stuff, and it's a little confusing to look at. I'm not even quite sure what's going on. But I can be like, okay, based on total calls, let's see. Start with string objects. Okay, there's a lot of calls to start with. And the per call time is ridiculously low, which is good. That's great. That's what I like to see. But the cumulative time is that's tenths, hundredths, thousandths, 5,000ths of a second. Cumulative and total to be the same. Oh, wait, but they're not. What's the difference? Total time and then cumulative. Oh, wait, I can hover. Cumulative time spent in this function and all sub-functions. Total time. Total time spent in the function, not including time spent in sub-functions. Okay. So I kind of want to look at the cumulative time. Jeez. And then there's a lot of calls to string length. I don't remember why, for the life of me that would be. So, I guess call stack. It doesn't really give me any details. It's in parse stuff. Line 161. So, okay. First of all, is there like close all tabs? No, I don't think so. It looks like close all editors. Maybe I'm not able to read. So it was 161. Okay, well that's not useful. So a lot of calls to string length. Was it parse base? Or sorry, not type base. Parser base. 161. Is there even a line 161? Oh, there's only to 137. Okay. So, maybe not. So there's a lot of calls to starts with. Which makes sense. How many... Okay, so there's a ridiculous number of calls to check. Okay. That's quite interesting. And a lot of calls to peak, which that makes sense. How many calls to... I guess there wouldn't be calls to it. What I can do is I believe in errors.py, what I had done was I can set this profiling flag to true. and I can make run. And did I remove it? I might have. Oh, you know what happened? I reverted a bunch of changes. I just went, right back to my last commit. It might be gone. I think that's exactly what happened. Which means I think a couple other changes, yep, are gone. Which is fine. I mean, I didn't really need those. I believe it was like maybe 200 iterations of the loop, but for each of those iterations there's a ridiculous number of rules, so it might make sense that there are a lot of calls to peek, check, etc. So maybe we should reduce those because, okay, let's look back at the cumulative time. A lot of the time is spent. So actually, yeah, let's sort by cumulative time. Compile, obviously. A lot of imports are taking a ridiculous amount of time. Code gen, that would make sense. A parse function would make sense. Actually, it doesn't seem that the parsing is taking that long. I guess the compile function does do a bunch of imports inside of it, and that is a large amount of the time. Like, that's the biggest time sink, I'd say. Also, let me delete this. Yes. I want to delete this whole build folder. There. I think I should also maybe work on docs today. I'm not quite sure. Not a lot of people on a Monday, I would have guessed. Module. Yeah. There's a lot of time spent in list comprehensions. Which makes sense. Yeah, I mean, that makes sense, honestly. Delimited. Yeah, so this delimited function takes a long time. And that's one of the reasons I wanted to remove it, even if it adds more iterations. I mean, doing the removal would let me better add things like lists. And only issue I usually have is it just causes weird issues. I think I should add a step that like just spits out a syntax error if there's a problem, but ignores ignores anything that looks completed or is a set of curly braces in order to just skip past things, because it would have to, like, what's the word I'm looking for? It's gone. It's just gone out of my head. It would have to. I had it. It's gone. Oh my god, how am I struggling so hard with this word? I keep forgetting what it is. It's on the tip of my tongue, and it's like it has to like collapse. That's not the right word, but like it has to collapse through. So if something way down in nested curly braces is fucked up, then the top level ones won't work. Which is why I need to like skip past and find the thing that isn't working. Which is the only disadvantage, because I got very easy like, oh hey, you're missing this delimiter. Which was nice. It was very easy to do that. Now it's a bit harder. I think now I can just throw like syntax error, you've got a big head or something. I don't know, like just some like I don't know really, like just insult them. Parser generator module. What? I am not using that. Did I import that on accident? I didn't. weird. I'm also going to do this because I can. Callable, if I remove that delimited function, I'm not going to need it anymore. And I think that might actually be pretty helpful. Also, these are immutable now, which is actually quite nice, and they're just named tuples, which I think reduces memory usage. Not quite sure. I think so. I don't think you need slots for them. Like, it is, I think you can't even have slots for this object, because it's a tuple underneath, and that's it. All it is a tuple. So, I mean, there's nothing to really do there. What is coming up? I really wish I knew what half this stuff was. I think actually some of this might be the SnakeViz thing. And some calls to it, but conditionals.py. Quite a high cumulative time. Weird. That's fine, I think. So, there's nothing I can do about code gen. This parse function can probably be faster. So what I had done yesterday, I'm gonna close so many tabs real quick. There's so many here. I had to open up like every file in the project. Okay. So what I had to do yesterday, because I think it is helpful, is I put a bunch of returns, because what I think happens is I'm not sure how Python actually does this when it like constructs a. I know it's an interpreted language, so it goes line by line. So I was thinking if I just return here, then I could just get out of it. No big deal. I was also thinking of finding a way to, if one of these gets, if one of the rules is activated and one of the rules matches up, then I really would prefer to just restart the loop right then. So even though it might be more iterations, there's less if checks that are likely not going to be useful. Plus, a lot of these if checks should probably start over because things have changed. Maybe that's worse, I'm not quite sure. This also seems kind of useless because there aren't a lot of simple rules like the return statement here, as there are with anything else, so not sure. Also, I have to make sure. So I want a statement and not a statement list, right? So when yeah, okay, so I only accept statements, and I changed it so that way blocks are also statements now. So a block is a statement, which allowed me to use them in the statement list node. Which is, or not node, token, the statement list token. Which is nice, it's very useful for me. Another thing I did, which probably increased iterations, unfortunately, was I made it so it'll say any unresolved keyword, like he doesn't know what it is. It's not a return, it's not an if, it's not a define. None of those normal language keywords. If it's just a random keyword, it'll automatically think, that's a variable probably, I will worry about the specifics later, just say this is a variable. And then it does, that's all it does. And as a side effect of that, now instead of a lot of things matching with keywords, they actually match with expressions, which is weird. And then you have to check, is that expression actually what I want? And that would be a variable reference, so just a reference to a variable. If not, then don't don't use it. But you know, anyway, I think a change I can make. I feel like this is EOF is not useful. A lot of the time in these checks, uh, but they're used as a band-aid, uh, instead of like inside of the check group, checking if there's even enough space beforehand instead of doing this looping for no reason. So everything is split up by spaces, which is really nice. So basically, my parsing rules easily are just like token 1, 2, 3, 4, 5, 6, and it'll just match this pattern directly in. It'll just slot that in. And basically it just generates a list of booleans and goes from there. What it should probably actually do is instead of looping all the way through, it should just stop immediately. Like, it should just say, this didn't match, bye-bye. Like, stop looping. Because for larger rules, I could save so much time, but I also know that list comprehensions are supposedly faster. I just realized, you know what I have? This fancy pants little thing, this little visualizer here. I can look to see how long those functions are taking. So, I want to look at the cumulative time, because I think that would count as a subfunction. And let's quickly make profile CPU. And I will look for the check group method. And actually, I'd want to look at the per call time. So the per call time is that. That's the per call time. The cumulative time is that. So we'll just keep that in mind for the time being, and we'll see if length tokens is greater than, and basically we'll just see so we want the length of the tokens plus the current start index -1, maybe? I think that's what we'd want. Self dot underscore cursor plus self dot, sorry, I want start underscore index. That's quite a lot. We'll fix that in a moment. And we want to see, is that less than the length of self dot underscore tokens? And if so, we will return false, because we can guarantee that, you know, it's quite quick. Really, this only saves time at the end, and I don't mean at, like, the end of our parsing. I mean, like, I mean, I kind of do mean that, because we don't really get to the end of the parsed tokens, or end of the parser tokens, towards the end of our parsing, just because of the way I've made this, but that should still be helpful. So let's make profile CPU, and we will look for check group, and time per call has gone down. That's it. So the cumulative time has also gone down. Now we have to check, is that a fluke, right? So you can't, I mean, I don't want to just, like, I was hoping maybe the results would have been average, right? That would be kind of nice. So we will check group again, and no, it actually significantly made the time better. So, I mean, now I can really simply do this. So what that actually allows is us not to worry about like EOF or anything. So like in our peaking, we might not have to worry about EOF anymore because we only ever check group, and if the group doesn't come back with anything, then the rule can't like peek into non-existent places, so we don't need to check for that. And the check group function here won't try to peek into random places anymore because we tell it not to. There should be an underscore check. Or I guess not. Did I remove that? Alright. I guess it's not exactly possible to check into non-existent space, but I don't remember. This is probably fine. Because it's an or, I think. I get Oh, it's maybe that's not fine. I don't know. Because we could just return it the first result. Not sure. Okay. We might be able to shorten that list comprehension down. So basically, we want to go through like this instead, and we'll say if this isn't true, then we will return false, and here we'll say we'll return true. This will hopefully save time. I mean, there's not really a good way to know other than doing it. So let's compare. It has, wow! The cumulative time is way lower. That's good. That's really good. The cumulative time is now this. Or let me just replace this so it's easier to see. Yeah, so it's about 4 times faster, which is actually a really, really fast gain when you consider how many times we'd have to run that function. So 4 times faster is pretty ridiculous. It actually might be an even larger order of magnitude. Just gonna look up times faster calculator because I'm a little lazy. So that's our start value, and we're just gonna do the per call thing, right? So I'd say like 59, 60% faster. That's great. Now my calculation is probably not perfect. Okay, where is the speed calculator? No, that's distance. I don't know how a lot of the time they calculate. I'm a bit dumb. I'm not gonna lie, a little slow. uh, oh, my back. Sorry. Just typing something. Back. Okay, sorry about that. That is really good though. I'm like super happy with that time change. That was a really easy thing to do. That's like not an inconvenience at all. And yeah, that was super easy. I'm thinking I could probably do this in a one-liner. I might have even been able to do this in like a list comprehension, like one-liner thing, but it would have been so hard to read. I mean, both are probably going to be hard to read, so I probably shouldn't. I know, again, list comprehensions are faster. Although I don't know if the speed gain should come at way harder to read code, because it's not really gonna... I'm not gonna get my time back there. Uh... That is much better though. This check group is faster. I think I can make this faster. Which is good. Uh, so yeah, I think I can. So what I can do is I think I could remove this, and the peak would be faster. So let's actually look at this peak function, and it is fairly fast. So I mean, it is a relatively fast function. Now, it's not used very often. Oh, well, I guess it does have a ton of calls. So I guess for cumulative time, it makes sense, but still. I accidentally hit Control C there. So, I mean, peak is a fairly benign function. Like, it's not doing much, right? I mean, that's kind of to be expected. But I'm wondering if I remove this, will this be any better? So I'm gonna see if I even can. So, and I shouldn't be able to consume tokens that are like that. So, hopefully, I can do that. So I want to just do make run, and that worked. Surprising. Whoa, why is it so fast? That's twice as fast as before. But parse time is way down. Maybe I'm not remembering. Okay, although the time here is like multiplied by some weird factor. So maybe, I mean, it's not a great test, but no, that does seem significant. Are these small changes really gonna make that significant of a... let's see, peak is... Wow! Like 5, 6, or 4 to 6 times faster. What? That is insane. That's pretty ridiculous. Let's... Okay, that's quite a lot faster. I imagine consume is also faster. I didn't actually benchmark that, but I do have old tabs open, so I mean, yeah, this makes sense actually. I'm not actually very surprised about this. It has 62 calls, so it doesn't really need much change. But let's look at it. I guess this one might actually be the one we want to check against. It is like somewhat significantly faster. I'd say maybe 20%. I mean, it's not. And 20% is like such a rough estimate. It might even be as low as 10. So it might not even be statistically significant. At least in my books, considering it's only run 62 times. So it's kind of... It's not really averaging that out. 62 times for such a function isn't... I don't know. Let's just look at the normal consume function. I guess is that not being called? I guess not. Am I really not calling this? Oh, because I'm using the replace function now, which only uses the underscore consume. So this never even gets run once. Guess that makes sense. This is quite a speed up though, so I'm pretty happy with that. So yeah, I mean that does reduce the cumulative time by a good substantial amount. Yeah. This moves the cursor, it uses this, I mean not exactly the best, but it does the job. Demove to true. Insert AST nodes. And it creates a new parser token every time, but that's not... Let's see that. Parser token. I believe that is instantiation time, and that's so low. Actually, it says it's only used once. Oh, I guess that's... Okay. No, that makes sense. So the init for a named tuple running 41 times, that doesn't seem quite right. Because I do believe it happens more often than that. Oh, SRE parser, that's not my part. That's not even my parser. I'm like, oh, what's this? Oh, no, sorry. I should probably show you what I'm looking at instead of just, you know, throwing it out there. So I'm looking at this. PS Linux. Weird. I guess. Alright. I don't even think it really registers. Let's, I guess, go back to, let's reset to the root, right? And we will say, let's sort by the highest cumulative time. It's an init for what module? What module are we looking at? Oh, LLVM light binding. Wow, okay. I mean, that's not surprising at all. So I can't really do anything, I think, about these module imports. Init.py here for what? Init.py for what? C types. Okay, I can't do anything about that either. Nodes. Okay. The init for nodes.py. Okay. Why would that be so high? Is it all the classes? It seems like the biggest cost right now is instantiation, because I think I've kind of made these little micro optimizations as good as I can do, because I mean these are going to be run hundreds or thousands of times, and it seems like it's like doubled the speed with very little effort. I'm very happy about that. But it seems like, I don't know, like the rest of this isn't, worth doing. I don't know. Like, okay, so there's math.py, so this is mine, and, I mean, the cumulative time isn't very high. So, I mean, it's only run 17 times, so, Lexer generator, why is 123? I mean, I am using a Lexer generator, because, I mean, there's no reason not to. It's regardless of whether or not I make it or not, it's still going to be a regex-based Lexer, because there's no reason not to. Like, I don't know, it doesn't make sense not to do that. At least in my opinion. I mean, there's a couple people who are like, oh, don't use regex-based Lexers, and it's like, why? I mean, you're matching up against patterns of text. I mean, it's like what regex is based, like, that's what it's for. I mean, why not use that? And it does a good job. Like, there's nothing really you could code that would be that much better, and if you do, it's really hard to read. Like, I've tried before, but it's not worth it to me. It's so much extra time for so little value. So, I don't know. Just my opinion. I mean, yeah, it's only getting run once. I mean, that's to be expected. Future.py. What am I importing from future.py? Line 83. I don't know. I could check that out later, I guess. Readers.py. A lot of these are only being run once. Enum, I mean, okay, I don't know if there's a way to make that any faster. Again, I could, like, use maybe not a Python enum, but I don't think that's really an option. So let's sort by number of calls. So, gen expression, this is for collections. Yeah, and I can't do anything about this. I don't even think this is me running it. Get item, get attribute. This is being called a lot. It's in C types, god damn it. Call stack, nothing. Is instance. Okay. Is instance slow? Is that cumulative? Actually, is this done by cumulative time? Or, oh yeah, it's done by cumulative time. I don't know. Like, I'm not sure there's much I could do, because most of the time spent is imports, and I can't just not import things into the language. I need everything that I'm importing, and even if I have something installed, I'm not even importing it. Like, there's a lot of things in the requirements.txt that are just for profiling. And then this is like the most basic I can get, and there's documentation that's not even being imported. So it's like these three things get imported. This one takes the most time in memory, and then like this just doesn't even account. Memory profiling was really useful, and I'm probably going to keep it in the requirements.txt because it's so useful, but I don't know. I don't know if there's anything I can do. Like, I genuinely think I've kind of just optimized as best I can. What I can do, let me make sure I'm correct about this. Are Python list comprehensions faster than for loops? Yeah, okay. So, what that tells me is can I guess the list comprehension. Okay, so the list comprehension's faster because it's generating a list of stuff, I think. I don't think it actually is, like, I think it has to do with how it does the list, like how it creates the list afterwards. Like, I'm not sure if it makes any sense, but I don't think it has anything to actually do with the looping being faster. Because regardless, it's still like using like a generator underneath. So I don't know. So maybe I don't know. It doesn't make any sense. I might be able to squeeze a little extra performance out of here. I'm not sure. Maybe by making this nicer. I mean, it is fairly ugly. I can also like I can fix this. That's the other thing I want to do. So let's get like the baseline performance of our check. Oh, I just realized I was looking through the number of calls. I was being dumb. There's a lot of starts with here. So is there a way to make this faster? uh, hmm. Is there a way to make it faster? There may be a way for me to like look at the beginning and then sort of chain the operations beforehand, I guess. And then just do it that way. I don't even know if that's worth it though. It would possibly use less memory, which is nice. The reason I think it would use less memory is because then I probably wouldn't be using recursion. So that could be pretty useful. I do think I can make this better, though, so what I will do is basically take this out of a list comprehension because it doesn't really need to be there, and I will say just if this, then return true, else return false. So that way, if it encounters any of them that are true, it'll just stop and extract and just stop looping. It will just give up looping because it doesn't need to anymore instead of looping over and over and over again. So let's get the baseline for this function, like I was going to. The cumulative time is somewhat high. I don't know. I mean, that's somewhat high for what this actually is. Okay. Let's go back to our check function. It's not even like appearing anymore. There. And yes, that did actually reduce the amount of time again, which is good. That is quite nice. I might try that like chaining operations thing. Because I think maybe creating less stack frames and doing all that, all those shenanigans might be faster. Not quite sure. I think after a certain point, my speed problems are gonna be unfixable in my code. Like, there's not really gonna be too good of a way without either completely refactoring or just it's not gonna be possible to get it to go any faster just due to language limitations. Which is fine. I mean, that's completely and utterly fine. Now, Python 3.11 is going to be significantly faster. That's all just to speed up just because. And I don't think I have anything in here that'll break between 3.10 and 3.11. I mean, I just don't know why it would. Like, I've looked at the features. 3.11 doesn't appear like it's going to be doing anything weird. So, yeah, I mean, this isn't... Okay, so what's nice is I do believe, like, making this faster actually makes this faster too, for obvious reasons, but, I don't know. So, let's see. Um, this kinda doesn't make sense. I think this can honestly be removed as a rule. I just have to see if I use it. I do. And this can be done like this. The only issue is that might make it slower. I don't know. That's the only thing, is I don't know if that's going to make it slower or not. So let's check. I feel like I should just put this in here. Like, I don't really need to do very much storage for something so benign. Like, it made more sense when I was using it multiple times. This might make more sense, but I'm still not even quite sure. So, let's do this, I guess. So, let's go to my insert here. Or not insert, the check. Check, that's what I want. And I'm going to put in the current timing. I mean, it's barely faster, and that's not like statistically significant in any way. So I'm not really sure I should worry about it, but ooh, list index out of range. How did I do that? Cursor plus index. Let's copy these. And we'll Control Z back to how we were. Here. Let's go to the stack trace. I guess if you're peeking ahead, why would you? I feel like I should have an underscore peek method that, like, just exposes this bare thing here, and then I should have a peek that actually does the check. But I don't really think it's necessary. So it's in the delimited function. I mean, that's not a surprise. I'm not sure how this makes any sense. What? How does that? Weird. That is very confusing. You know? That doesn't make any sense. That is very confusing. What? 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 So, was it this one that was broken? Okay, well, I'm a little confused how that makes any sense unless I like messed up somehow. I mean, that's possible. I mean, yeah, but a little confusing. Weird. What? Oh, I see. I see what I did wrong. I know. I know what happened. Because I use that same index here. Okay, in which case I think it actually still then makes sense to store this as a variable, like just on the stack. I don't think that's a big deal, and this only gets called a couple times. That's not a big problem. It might... no, I'm not sure. So, in any case, let's make profile CPU. Let's look at our check function. And is it any faster? Not significantly. Which, I mean, that's exactly what I expected. Have one from 5 seconds ago as well. Yeah, not significant in any way. So, that's fine. I mean, like, it made it ever so slightly faster, not having as many if checks, but we can... So... I'm gonna think... That is faster. Is there a way to, like, get this done first? Like, can I just check, are there no special symbols? If so, skip straight ahead, right? Like, because most of them don't use special symbols. I think, like, first and foremost, maybe I should put this there. Because this is super common. So, putting it there first makes a little sense. Cool. The time is ridiculously low, which is awesome. I'm quite happy with that. So, okay, let's continue to look at this check function. And no statistically significant change at all. Actually, exactly the same, which is good to know that the order doesn't make sense. Or that the order doesn't affect anything. I don't know. Did I just say doesn't make sense? Oh, oh, this is per call with or without the sub-functions. Yeah. There's a lot of calls to check. Set. Okay. Sorry. Just trying to think. as much I can do here. So I actually did like the previous order just because of the way it looked. What is if not X? Yeah, it doesn't make any sense anymore. I think just removing that check is probably what's best. um, that did make it faster, actually. Not again, not significantly, but it did make it faster. I'm kind of wondering. Oh, there are two numbers that means function recursives, and the first, the total number of calls, and the second is the number of primitive non-recursive calls. Oh, 1,000 recursive calls happening. That's quite a lot. Maybe then it might be worth do that thing with the operations. Let's reduce the amount of recursion, but the recursion is such a small thing. If it comes down to it, it'll do it, but I don't think it's necessary, in all honesty. Maybe in replace I should have it do like something really easy. Yeah, I think that's really that. So let's just do make unit test. It ran. Expected 2 failures, got those 2 failures, and expected 2 successes, we got the 2 successes. That is exactly what I want. So now, in errors, I'm just going to set this back to false. And this can actually go away entirely. It's good for me. I don't... There's a main.html? Am I blind? I don't see it. Tests random. Oh, there is. Yeah. Move it to the trash. Okay. Now, we can do this, and small ooh, wait. Right here. And we're good. So, small optimizations to check group peak. Right, I did peak too, right? Was that consume? I don't remember what I did it for. I think it was primarily check group. I think I did peak as well. I don't remember. So let's sync these changes up. No, whoops. I just honestly want to push. Oh, done. That is simple. I'm going to go grab a water. So I will be right back. This time I'll actually remember to put the text up. So, maybe like 5 minutes? I don't know. Well, I just realized I haven't had my microphone on this entire time, but I do have to go again, so I will be right back. Did I like seriously get like a high viewer count? How many? It's like 6, 7? I got 7 people while I wasn't even here. Wow. Bad timing. Okay. Um, yeah, that's that's fun, I guess. Okay, so how was I gonna do this? Right. Let's just clear this real quick. And what I needed to do, was a bit of something. And this is really bad. This is so bad. Uh, hmm. Okay, here. That's what I wanted. We are just gonna ignore all of that for now, right? And we're just going to say if check group, and we're gonna start from the 0th index, obviously, like we're not gonna do any offsets. And then we're going to want to say basically if there's an expression and a comma. I think that's it. Or I guess so expression, comma. Is there anything else I could need? Let's see. Okay. So expression, comma. Am I gonna say... So how was I doing this before? No, yeah, I'm gonna want expression, comma, expression. But I also can have... what else? Expression list is a node I'm going to want to create. And then we're gonna say if... so actually, let's get the first expression, and that is going to be... let's see. Sorry, I'm trying to think as I do this and talk, and it's a little difficult. Sorry. Let's see. So yeah, right. I forgot. Sorry, I am getting real off focus. So yeah, we just want to get that, and then I guess we really just, or no. So we're gonna want to say if expression.name is equal to expression list. Hold on, sorry. Okay, sorry about that. So, we will check for this, and then we're going to want to say expression dot trying to think, sorry. Expression dot value dot add child, I think is the method I'm gonna want to create in a minute. And we will simply just self.peak, and that is the second item. Yeah, that looks correct. Or, well, technically third, but it starts from 0. So, that looks good, and then, yeah, then I'm gonna want to see, is it an expression instead? And also, I guess I could say expression. No, I guess it doesn't make sense. Maybe try like an output variable, I think. Yeah. I'll just say out. I mean, we'll send it to none for now. And in all honesty, this can be else and just save some computation. Let's see. And then instead, actually, and then we're going to set the out equal to expression.value. And then here, we're going to want to say out is a new ast.nodes. I think I'll probably create an expression list node. So that's gonna need I guess I really don't want this to have a position, so I mean this can just be set to a bunch of -1s, because it doesn't, it really just consists of other nodes. It only needs to work on the positions of other nodes. So yeah, I think that's good there. And I forgot how I was gonna do this. These should seriously be tuples. But they're not, so I'm not gonna change it for now. Alright, so in nodes, I will right under statement list, create expression list. I think that's good. So there. I think that's good. In all honesty, I don't actually think I need this for this one. I think I might just use the same, like, blocks stuff. Like, I might use the same queue that I have. I guess it's a stack, not a queue. Anyway, we will do self.replace. I always forget what that's for. Oh, length. Why is it not called length? Oh my god. Yeah, that, like, that doesn't... Yeah, that's so much easier to read. Length, there. This is 3. And I think name is going to be expression list, and the value is going to be, what is the value here going to be? Right, out. I'm sorry. I'm getting, like, really flustered for some reason. How long have I been streaming? That could explain it. Okay, anyway. Basically all I want to do for this. What's, oh, I forgot the self dot. Okay, that's a bit better, and I've made this. Now, I think, what do I want to put in it? And that's probably, actually, I think I want nothing, right? Like, I want nothing, and then I want to do out dot add child self.peak 2, and then I'll do out.add child self. Or actually, I already stored it. That's why I was doing this. There's no add child? That's weird. Yeah, there is. Append child. Okay. Whoops. This is expression. Oh, right. Expression dot value. And this also needs to be dot value. Okay. I think that's a little better. I think that's exactly what I want there. And this needs to be dot value. I don't know why that's not throwing an error at me. Weird. But that looks to be alright. Gonna replace the old ones with the new. Okay. That looks good. Now, I want to say elif, and let's say, oh, right, and I forgot, I've been trying to do the new thing of putting a return at the end, so that way it doesn't try to continue down the chain. Although I don't think it would, I just don't know how Python likes to react. It probably automatically, I mean, yeah, it'd probably have to parse down to jumps anyway, I guess, yeah, so. Maybe these returns are redundant. Which is, should probably remove them, but for now, I'll do benchmarking later and figure this out. So we're gonna say if we just do self dot and then we'll have a normal check, and we will say 0. We're going to want. This is going. You know, so do it in single quotes. It looks like. I feel like I keep mixing them. Yeah, I should make that a normal style. I think I can actually, in the, I forget what it's called, but like the styling thingies, the automatic, like PEP8 formatters, I think I can set custom rules, and, one of them can be like, oh, only have single quotes for characters and double quotes for full-length strings, because it's kind of the pattern I've been trying to go for, but I also then just go for whatever is being used in the actual. It's weird. I've got to kind of commit a little better to whatever I'm actually trying to do. So maybe having a little thing telling me would be nice. Okay, we're gonna want to check, and we're gonna want to say if this is an open parentheses, then we're going to want to use basically the same rule that we use for this one, which is pretty lengthy, in all honesty. Very lengthy. So we have an output, and instead of a... I'm thinking, honestly, I should just... So, the reason I did it with the blocks is because the blocks are used pretty often in setting variables, but I think I should set it to none. So... yeah. Or maybe not, because... I'm not quite sure what I want to do. I guess for now, I'll keep it as this, because, I mean, at the end of the day, it doesn't really matter. The memory usage doesn't get badly affected by this in any significant way, so... I don't know. Let's do... yeah, parenth block, that's what I want. And... this is useless for that. And we're gonna say open and used, and it's gonna have this as the value. Yep, that works. Now we append these to the current blocks, and we just do the stuff with the cursor. I think I am gonna remove all these return statements, these empty ones. I think I'm just gonna manually go through. I mean, I think that's the easiest thing. I really shouldn't have added these. They're redundant. I mean, it has to become a jump at the end of the day anyway, so it's not like it actually matters in a meaningful way. So, not sure why I did it this way, but I did, and it was a dumb idea. Might actually be more deleted lines at the end of the commit if I keep doing this. So, let's keep doing this. I just thought an early function return might be useful. I don't think it's a sustainable like pattern, and I don't think it's a very good little micro optimization that really does anything. There. Okay, that's all removed. Now, last rule, we're gonna have self dot, and then we'll check a group of tokens, and it's going to be open paren used, because we want to make sure that we've actually visited this, and it's going to be an expression or expression list, and then it's going to be a closed parenthesis. And basically, we're going to copy what we did up there. 4 blocks. So, this is what we want. Alright, this is going to let us define... I guess it... Sorry, okay, I'll worry about specifics later. And I'll write a better unit test, so we'll just check there, I guess. Bogged out lines, but it doesn't... I know that... Whatever. What am I building? I'm writing my own programming language. So right now I'm in the parser, and I'm replacing some code that I don't like, and so that way I can have an easier time adding something else. That's gonna be aggregate types, that's list, vectors, that kind of thing. So that's the hope. I don't know how far I'm going to get in doing that today. But, you know, hopefully I can get decently far. So, let's see. Instead of a statement, it's gonna be... I guess, should I just... I guess I need it to be one or the other. Let's just have a name variable, which is by default it's just gonna equal expression, and we'll do name, and then name is going to equal parentheses, because I have it separated so that way you can't do math on, like, you know, if you have in parentheses like 1, 2, 3, that kind of thing. But you kind of do math if you have like in parentheses 8 plus 10, like that's fine. Which is why I need to do that, like separated. I mean, I could actually just write better rules, but where's the fun in that? In all honesty, that might even save time in a couple of places, like actual runtime. I'm not sure. I'll figure that out later. Let's see. I think that is good. I have it using probably the wrong stuff because it's using a queue that it probably shouldn't use. Because I have, instead of using recursion, I decided to start using queues for the block parsing. And so I'm using that same queue, which I think should be fine, but it might not be. I don't know. So I think this should just work. I don't know, but it looks like it should. So maybe it will, maybe it won't. Who knows? Whoa, what happened here? It's no attribute variables. Yeah, that would make sense. Close paren. Oh, right. Oh, and I should make that a rule for the... That reminds me. That is correct. I need another rule. And this actually, I should change the order. This needs to happen before this. This is a very, very basic rule. There. And just gonna do self.replace. It's 2 in length, and it's just gonna be a... I guess it's a parent object. Did I have this as an expression before? Would have been bad. I hope I didn't, because that would have been really stupid. Would have been really, really dumb. I think that's what I want right here. New print object, empty, and call it a day. That is good to go. Is there anything else I would need to do? Nope. What? That doesn't make sense. Line 99. What's happening on line 99? How have I done this? How have I done this? Here. How do I do this? Wait, no, that still doesn't make sense. It's the wrong one. What am I thinking of? Huh? So this is true. Then why would this fail? What? Why would the list index be in range? Oh, it's in line. Huh? That doesn't make sense. Why would it be doing that? It doesn't make sense at all. Uh, oh, time to print out some debug code. Should probably go. I mean, I'm getting a little tired of streaming. I'm not sure yet. How have I done this? Define its multiple. Oh, I know what I did. I'm stupid. I know exactly what I did. Oh my god. Okay, I mean, that's fine. That makes sense, actually. I forgot that's a completely separate node. Oh my god. I should have seen that coming. Let's see. Parentheses, blocks of parentheses. And we will do this. What? Get variable. This all looks correct, right? It could be very wrong. Could be very wrong, but I don't see why that would cause an error. New function definition. So it parsed down to the end. But why would it? Okay, I guess I can. This is a pain. So those return keyword is function def portion. Not complete yet. Then there is a open closed. There's return open paren, so then it's here. There's a variable reference. Watch a little. A variable reference. Looks good to me. So that should be turned into an expression at some point. Yeah, expression. Did it in one step. Like instantaneous. Okay. I mean that's possible. It's just not what I expected. So that becomes an expression. So return expression. Expression EQ a number. That number should become an expression eventually. Yep, there we go. And that resets. Expression, which should get turned into an expression. Map comparators. Yep. And then that'll reset to here. Turn an expression. The statement, curly braces is all good. So why do we have issues? Why would I have issues? My guess is down here, we're not popping the old block off the stack. Trying to think. I don't believe that's the case, right? Let's do some printing, I guess. We'll see what happens. What's the issue? What would the issue be? Damn, I've been streaming for 2 hours. Should probably stop streaming. Yeah, I should probably do that. Okay, I'm gonna solve this off camera. You can start the project on GitHub if you're interested in following its development. I can't promise it'll, be done anytime soon, or if I'll even finish it, but, I mean, it'll be fun while it lasts, so do what you want. I'm gonna stop streaming, so see you later.